Hello, welcome to this presentation on this topic of Smart Zinc, a new concept fertilizer. I am Chandrika Vardachari, a scientist and researcher, and presently the Chief Technology Officer of Actec Innovations. I'm a PhD in agricultural chemistry and soil science. The focus of my research since the last 35 years has been to develop new fertilizer materials that will be environment friendly. I'm the inventor of a brand new type of fertilizers that are smart. Smart Zinc is one such fertilizer that I have developed. The element zinc is a micronutrient fertilizer. Plants require the macronutrients, nitrogen, phosphate, and potash in large quantities, but they also require micronutrients, zinc, iron, manganese, copper, boron, molybdenum in much smaller quantities. Nevertheless, micronutrients are extremely essential, not only for plants but also for humans and all animals. Plants are the ultimate source of micronutrients. Micronutrients are the building blocks of essential enzymes and proteins. Like iron is a component of hemoglobin in our bodies. Micronutrients are required in addition to the macronutrient NPK fertilizers. Zinc is the most important of all micronutrients in terms of its usage and trade. Micronutrient fertilizers improve yields of crops, reverse soil fertility degradation, and increase the nutritional quality of the food. What are the limitations of the fertilizers that are currently in use, and why do we need newer products? First, water solubility. Almost all of the macronutrient and micronutrient fertilizers in use are water soluble. They can get leached out of the soil or drain out into the groundwater. This causes water pollution. Water soluble nutrients can also get firmly fixed or trapped by soil components. They can also react with other chemical constituents and form precipitates. Thereby, they are transformed into non-available forms which plants cannot use. Adding water solubles also creates a huge mismatch between supply and demand. For example, all of the zinc fertilizer that is required for the entire life of a plant is added in the initial stage. When the plant is young, there's a huge excess of zinc. Over time, the zinc becomes non-available, but the crop's requirement increases. At this stage, the crop does not get enough zinc. Thus, there is a situation of either oversupply or deprivation. Well, consequently, the use of conventional fertilizers, which are all water soluble, results in dosages which are in huge excess of what is actually required by the plant. To give an example, for 1 hectare of wheat requires just 500 gram, 0.5 kilogram of zinc, but we are adding 5 kilogram of zinc as zinc sulfate. So all the nutrients which are wasted are polluting waters or soil. This can result in contamination of groundwater, lakes, and oceans, causing algal bloom and death of aquatic life. It can cause deleterious effect on soil properties. Lastly, such a low utilization is obviously a huge wastage of resources. A large chunk of the farmer's investment is literally going down the drain, and nations are depleting mineral resources faster than they should. So then, what is the alternative? Are there any solutions? One general idea is, since water solubility is the cause of these problems, why not make fertilizers insoluble? But then, do insoluble materials make good fertilizers? No, They do not function as good nutrient sources because plant roots cannot pick up or absorb nutrients from insoluble sources. But the paradox here is that a good fertile soil itself contains very little nutrients in soluble form. By shaking a cup of soil with water and analyzing it, we will find very little or no zinc in it, or for that matter, very little of any other nutrient. So soils have nutrients in insoluble forms. For example, this evergreen forest soil supports a huge biomass of trees and plants, but has insignificant amounts of soluble nutrients. So, how do plants do it? How do plants take up insoluble soil nutrients? They do it by an extracellular digestive mechanism. They secrete organic acids and enzymes that dissolves the soil nutrients and helps the root to absorb it. This is similar to the digestive process that occurs when we eat insoluble foods like a boiled potato. Our stomach acids and enzymes break up the potato into soluble forms that pass into our blood. The process with plant roots is illustrated here. A plant root is near an insoluble nutrient source. The root secretes organic acids, which extracts the nutrients from the insoluble source. The nutrient is absorbed into the root. However, the critical issue is that plants cannot use any kind of insoluble material as a nutrient source. This is similar to the fact that we humans cannot digest straw but can digest spinach. What this means is that only certain kinds of insoluble materials having certain types of molecular structure and certain types of insolubility can be good nutrient sources. The insoluble source has to be the spinach kind, easily digestible, and not the straw kind, which cannot be digested. Well, so what this amounts to is that nature has a simple mechanism by which it provides just enough nutrients to plants as and when required. So it can provide nutrients to plants in a sustained manner without overdosing or underfeeding, and all of this from insoluble sources. So if we want to produce the perfect fertilizer, we need to mimic nature. And this is exactly what we have done. Our smart solution to the problem is to let plants decide when and how much of their nutrients they need. And how do we do that? We design molecules that will be water insoluble but plant digestible. In a generic way, that's what our smart fertilizers are about. So, coming to the specific case of smart zinc fertilizer, how does it work? As we know, plant roots release enzymes and organic acids for the purpose of picking up soil nutrients. Smart zinc dissolves in these root exudates and is absorbed by the plant. As the plant grows, its root system grows too, and it releases more biochemicals for absorbing more nutrients. In this way, nutrient release is controlled by the plant itself. What is smart zinc? Smart zinc is a zinc fertilizer with a unique polymeric structure which has been designed to mimic the natural form of nutrients in soils. It is insoluble in water, so there is no leaching, no fixation, and no nutrient loss. It is soluble in root acids, so it is plant digestible. It contains 100% plant food. All of its chemical constituents are plant nutrients, so there is no unwanted buildup in soil. So basically, the effect of Smart Zinc are the following. Nutrient is available to the plant throughout its life. Plants can take up the nutrients as and when they need it. The plant gets the exact amount of nutrient, that is zinc, right from start to finish throughout its life. This eliminates the mismatch between plant need and nutrient availability, which occurs when we add soluble fertilizers. It contains 100% plant nutrients, so no toxic residues in soil, there is no soil acidification, and there is no leaching, and so no environmental consequences. What are the chemical constituents of Smart Zinc? Smart Zinc contains phosphate and magnesium apart from zinc. Both phosphate and magnesium are plant nutrients. Here is some technical info on Smart Zinc, the composition. Its major constituents are 19% zinc, 8% magnesium, and 15% phosphorus. It is soluble in 0.005 molar DTPA and 2% citric acid. Both these are reagents used for assessing zinc, and solubility in these reagents indicates zinc availability. Smart Zinc has a three-dimensional crystalline structure which consists of units of small chain polyphosphates, zinc polyphosphates, interlinked with magnesium. Chain lengths and nature of interlinks are optimized to obtain a molecule with desired solubility properties. Smart Zinc provides a huge package of benefits to the farmer. Dosage requirement is reduced by 90%. Only a tenth of the regular dosage of zinc sulfate is required. Even at these reduced dosages, crop yields increase substantially on an average of about 5 to 10%. This provides a very high return on investment to the farmer. Besides this, the crop is also nutritionally enriched in zinc, thus providing a significant health benefit. Dosage for Smart Zinc is 3 kg for 1 hectare in all field crops like rice, wheat, potatoes, vegetables, etc. 3 kg of zinc, Smart Zinc translates to about 0.5 kg of zinc as elemental zinc. It is 4 kg per hectare for long duration crops like tea, coffee, plantations, trees, citrus, sugarcane, etc. Smart Zinc can be universally applied to all crops, including all cereals, legumes, vegetables, plantations, oil crops, and long duration crops. And how do we apply Smart Zinc? Smart Zinc is a basal fertilizer. It is to be applied to soil during sowing or transplanting. Ideally, it is applied as a band placement just below the root zone, 2 inch by 2 inch below. For crops like rice or corn, it may be broadcast on the soil. The powder form can be mixed with macronutrients like urea, DAP before application to improve spreadability. For vegetables, it is to be applied along the rows near the root zone. Suspension form of this fertilizer can also be used. Only one application is required except for long duration crops with life greater than 6 months. So the various ways in which smart zinc can be marketed include as a mixture with NPKs, as coating on urea or DAP or MAP, as a powder itself, or as a suspension for drip irrigation. Apart from zinc, smart fertilizers have also been developed for phosphate, which is smart phosphate. Smart fertilizers have been developed for other micronutrients apart from zinc, including iron, manganese, copper, boron, molybdenum, and selenium, and for phosphate fertilizers which also contain any or all of the micronutrients. We can also make combination micronutrients for specific crops, such as iron manganese fertilizers for oranges and turf, zinc boron combinations for potatoes, or generic combinations containing all of the micronutrients. These are some selected results of our trials with smart zinc. Here, smart zinc at low dose, 0.5 kilogram per hectare zinc, is compared with zinc sulfate at regular dose, which is 5 kilogram per hectare zinc. These were all statistically designed trials conducted with 6 replicates and statistically analyzed for significance of results. Smart zinc at the rate 0.5 kilogram per hectare zinc produces 19% yield increase in rice compared to 6% with zinc sulfate. In another region, smart zinc produced 23% yield increase compared to no increase with sulfate. Cabbage produces 12% yield increase and potato 27% increase, while yields are much less with zinc sulfate. Similar results are also seen with green gram, or mung as it is called. This is a trial conducted in northern Vietnam with rice. Application of smart zinc yielded 15% yield increase compared to the control plots. It also produced a significant increase in rooting. There was also an observed resistance to lodging during floods. Another trial in South Vietnam showing similar results. After many such trials, the Vietnam government has approved smart zinc for sale in Vietnam. Many other field trial results are also available, done independently by independent entities in US and also in India. Over 24 independent trials were conducted by large fertilizer companies in India, and these showed significant yield increases over zinc sulfate at 1/10 of the dosage. Return on investment was about 2 to 3 times more than for zinc sulfate. Independent trials in US showed significant rooting effects of smart zinc and 2.5 times higher return on investment over zinc sulfate. This is a rice trial conducted in Arkansas. Cantaloupe trials in Arizona, when treated with smart zinc, gave 28% yield increments with 850% return on investment. This is comparing with zinc sulfate treated plots. The use of smart zinc has a significant impact on nutritional value of crop, with increase in zinc content. This will be a boon for improving zinc deficiency in humans, zinc being the 5th most important cause of disease in the world. science behind this fertilizer has been extensively researched and is published in top-notch journals of the American Chemical Society, Elsevier, among others. The technology is covered by 3 global patent applications. Patents are granted in 11 countries. That includes the US, Canada, Australia, China, Israel, etc. For this technology, I have won the UNESCO Roscar Award. I have also been awarded the Lockheed Martin India Innovation Gold Medal as judged by an international team of experts from the University of Texas at Austin and FICCI, Federation of Indian Chamber of Commerce and Industry. The presentation ceremony where the award was given by the Vice President of Lockheed Martin, Dr. Ray Johnson, and here is former President of India, Dr. Abdul Kalam, discussing the technology with me. For further information, I can be contacted at this address in India, or our CEO, Mr. Murali Vaidachari, can be contacted in the US. Thank you. I hope you enjoyed this.